This is the video for section 2.4, and today we're going to be talking about dividing polynomials. Now we're going to use what we call synthetic division to divide polynomials. The great thing about synthetic division is it's going to eventually help us get the roots or the solutions of a polynomial without having to factor. Because if we look at this first example here, this given polynomial, the x cubed plus 4x squared minus 5x plus 5, we can't factor that with any of our known ways to factor. So that's when we'll go to this synthetic division. Before we go through the example, one thing we have to know is that if we want to do synthetic division, notice in this case we're dividing by x minus 3. The degree of what we're dividing by has to be 1. So it has to be x plus or minus something. It can't be an x squared or an x cubed or anything else. If it is, then we can't use this method of synthetic division. We'd have to use long division, and we're just not going to talk about long division right now in this class. So here we go with synthetic division. The first thing we do is set up a picture like the one shown. Now in the little box, you're going to look at the x minus 3, and you're going to take the opposite of the minus 3. So it's going to be positive 3, and that's what's going to go in the top corner. The next step is just to list out all the coefficients of your starting polynomial. So 1x cubed, 4x squared, negative 5x, and 5. And then we're going to go through the synthetic division process. So here's how it works. You start by dropping down the first number. So we're going to drop down the 1. And then you multiply 1 times 3, and we get 3. And then we're going to add 4 and 3 to get 7. And we just do the same thing again. We multiply 7 times 3, and we get 21. And then we add negative 5 plus 21, and we get 16. Now we multiply again. 16 times 3, and we get 48. And now we add, and we end up with 53. These will be the coefficients in our answer. To get our final answer for our division question, we're going to take the x cubed, and we're going to drop the exponent down by 1. So we're going to have an x squared now, and its coefficient will be 1. So we get 1x squared, and now we just list them out, and we just keep dropping the exponent down 1. 7x plus 16. I don't really know what to do with the 53. This is what we call the remainder. So in math a long time ago, you'd put, for example, R53. And then we learned we don't write it that way. We know it's 53 out of whatever we were dividing by. So we're going to say 53 out of x minus 3. And that would be our remainder. Let's take a look at another example. So we're once again going to divide these two polynomials with synthetic division. Remember, the first thing you do is take the opposite of what you're dividing by, the x plus 2, and you put a minus 2 in the box. Now we're going to go ahead and list out our coefficients. Now notice that there's no x squared term. It's really important we remember a 0 placeholder there because there's no x squared term. Now we're just going to go through and use our synthetic division. So we drop the 5 and multiply, add, multiply, add, multiply, and then we need to add again. And we get negative 44 as our remainder. When we write the final answer, remember we take the x cubed and we drop the exponent down by 1, and we use the coefficients below. So we have 5x squared minus 10x plus 26, and our remainder we put over x plus 2. And this will be our final answer if we were dividing. Right now, we're really just practicing the process. We're going to see later on how this is going to help us move further in our graphing of polynomials. Go ahead and pause your video and now try this one on your own. Now in this one, hopefully you got a remainder of 0, and this is going to be really great. In the future, this is what we're going to be looking for, our remainders to come up as 0. So that means if I was to rewrite this, that I could rewrite the answer as 2x squared plus 3x minus 2. Now, just taking a second and thinking a little bit further on this idea and where we're going to be going with this. If the given polynomial divided by x minus 3 equals 2x squared plus 3x minus 2, then working backwards, I could take the answer and multiply by x minus 3, and I would get the polynomial I started with. This is where we're headed. You can see a little bit now how synthetic division helped us factor. So that's where we're headed. That's where we're trying to go. Now, let's go ahead and use this factor theorem to actually solve an equation. So how can synthetic division help us solve an equation? Now, I don't have a division question to start, but notice that I know that 3 is a 0. If 3 is a solution to this equation, then I know that x minus 3, the opposite of that, would have been one of its factors. So I know x minus 3 times something else would give me this original polynomial. Because 3 is a 0, I can take the opposite of 3 and get x minus 3. That will be the factor. And I know that factor times something else will give me what I started. Let's use synthetic division to try to figure out what that something else was. So we'll put the 3 in the box. 2, negative 3, negative 11, 6. Now this is actually the previous question we did. Try again. 3 times 3 is 9. And we can see that we get that 2x squared plus 3x minus 2. So that means that that times x minus 3 is that original equation factored out. If I want to find the zeros here, I need to factor again with the 2x squared plus 3x minus 2. So we'll go ahead and use a diamond and a rectangle to factor. We're looking for two things to multiply to negative 4 and add to 3. So 4 and negative 1. And we'll go to the rectangle now. And we'll put those answers in our rectangle. It looks like 2x squared is going to be broken up into x by x, so we get minus 1 and plus 2. So that means the factors here are x plus 2 and 2x minus 1. And we still have that x minus 3 from before. I can use the zero product property here and get negative 2 as a solution, positive 1/2 when I add 1 and divide by 2, and the x equals 3 we already knew. And now I used synthetic division to help get all the solutions to my equation. Let's go ahead and look at another one. We know that negative 1 is a 0, so we know for sure one of the factors of this polynomial is x plus 1, and I want to solve. So we'll start with our synthetic division. We'll put the negative 1 in the box, that's the 0, and list our coefficients. And we'll just go through our process. Drop down the 15, multiply, add, multiply, add, multiply, and we get 0. And this is good. We want a 0 there. We don't want to have a remainder now. That's not going to help me much. So I know I have x plus 1, that's one of the given factors. And then I'm going to have 15x squared minus x minus 2. And that came from our coefficients, our synthetic division. We now need to solve this equation, so we're going to have to factor again. Let's go ahead and take that inside, that second piece, and we're going to multiply 15 and negative 2, negative 30, add to negative 1. Let's see, 5 and 6, we'll make the 6 negative. Put the pieces in the rectangle. So we get negative 6x and 5x. Now, 15x squared, we're going to need to break this up into 5 times 3. So I'm going to put the 5 on the top and the 3 on the side here. And we end up with negative 2 and positive 1. So there are our factors. We've got 5x minus 2 and 3x plus 1. If we now solve these equations, we get negative 1, positive 2/5, and negative 1/3. And those are our 3 solutions. If you're wondering, for example, where the 2/5 came from, we just used the zero product property and added 2 and divided by 5. Same idea with the 3x plus 1. I subtracted 1 and divided by 3. All right, so here's one for you to try. You're just going to divide right now. You don't have to solve this equation. So I want you to use synthetic division here, and I want you to bring this to class tomorrow.